Thank you. Jan, Jan didn't give me an equation, but he did choose the title. And I put a subtitle on there, which hopefully I'll come back to, but you've got me ahead of myself. So, look, it's as with everyone else, it's a great pleasure to be back here. Thanks for the invitation. It's a fantastic opportunity to catch up with some friends. Okay, there we go. It's quite a long way. People confuse Australia and New Zealand quite often, but it's yeah, I know. There we go. Phil and I live 2,500 kilometres away from each other, so it's not that close. I'm going to talk broadly about three things today, which might not necessarily answer the proposal Jan gave me. Firstly, I'm going to talk about our, if you like, journey with fresh gas flows. I'm going to address the issue of whether looking at fresh gas flow tells us is a suitable endpoint, not necessarily the right endpoint. And then I'm going to finish by talking a little bit about how we maintain the sort of fresh gas flows that we have. There's a lot of connections. Speaking late, I get the opportunity to bring a few threads together. Here's a bit of my bookshelf with some familiar names on there. It is a real nuisance that theses no longer come now in electronic form, so you can't stack them all up. Anyway, we've been looking at fresh gas flows for 23 years now. Here's our sequence up to about August. We're running an average of about 800 mils a minute across a whole case and across a whole variety of practice, and I'll come to what that looks like in a moment. I sort of, like many of us, discovered anaesthesia by accident, decided it was a group of people and topics that I enjoyed. I had absolutely no interest in pharmacology, but of course, though some of us in the room will remember that the only information we had were elimination, half-lives and terminal distribution stuff, which was completely irrelevant. And I wasn't interested in research, but I did get involved in some computer-aided learning programs very early on in my training. Of course, pharmacology, peak pharmacodynamics is really important for anaesthetists. This is the onset time for caffeine. And it is fascinating how if you show this drug to trainees, this graph to trainees, they start to understand a lot of kinetics that they don't get about, they can recite propofol and thiopentone and what have you numbers, but they don't understand them. You show them this, suddenly they understand where it's all coming from. A couple of my interest themes have been collecting and making use of lots of data, and then early in my career, the whole PKPD and TCI world was starting to explode. And one of the themes, I guess, which has driven me is merging and thinking about volatiles in different ways. And we've had some discussion around that today and much beyond MAC. You can see on this machine, this is probably mid to late 90s. We're already doing some data collection. I may or may not have been directly injecting isoflurane into the circuit that day. I don't think it was actually, because the oxygen flow is too high. This was a slightly earlier foray into PKBT stuff, a very simple way of getting a constant rate propofol infusion, a BET type scheme, which basically simulated some of the early step things. Yes, I used it on patients. It was absolutely hopeless, but it was an interesting exercise. And early on in my career as a student, I'd been exposed to this model of anaesthetic uptake and distribution. You can pick its age by the type of screen display. Part of the work for my thesis, I took this and improved it, and if nothing else, made it look prettier. When the Datex ADU arrived in the mid-late 90s, we had the ability to electronically capture gas flows and dial settings as well, and it allowed us to assess that old model that I'd inherited, which turned out to work and predict end-tidal concentrations quite well. So we updated it, slammed it on a lot of the anaesthetic machines, and you can see we were estimating the brain concentration, the effect site concentration. And again, it was a really useful tool, and really speaks to the theme that a number of points, and there's, which has been made several times, is that basically the further down you get the control chain, the more stable your anaesthetic will become. And of course, this is on a number of commercial systems now. We know this about fresh gas flows. We've heard some of this stuff already this afternoon. Since 2018, we've been using GE Insights to collect data, which gives us a lot more data. The why, we'll flip over that because you mostly know that. Our first attempt at collecting data, because now we had the system where we could, was interesting that we collected some data, did an educational exercise, and then collected it again and found no difference. But when we went back and measured it 5 years later, we found the gas flows had fallen anyway and carried on falling over time. The ISIS within tidal control, it's interesting that we had that bump up. There's an interesting exercise in interface design around about that. The data on the right is mostly from North America, and the interesting thing about that is that a lot of studies, less so now, but historically have excluded the early phase of anaesthesia, either because they've used start of surgery as a start time for their data collection, or there's UK data where they don't count what happens in the anaesthetic room, whereas we've always included the whole case. This is interesting to the point about automated control. You can see there that basically as our use of automated control went up, as we became more trusting of the technology, our fresh gas flows went down. This is not a talk about the Insights platform, but this is just a screenshot of part of the home screen, and there's a breakdown by every single theatre, and I'll talk a little bit about some of the data that's in that, but this is the platform we use now for looking at data. We were involved in prototyping this, and when we were looking at it, some of the concepts that were alluded to earlier about the impact of what you do early in your practice became very apparent, and we developed and published this conceptual model by thinking about there are basically three things we can control in terms of the total fresh gas flow distribution. If at a simple level you can control what the maintenance flow rate is. You have no control over, we know we have absolutely no control over how long the maintenance phase is. And then if there is an initial high flow, you can control both the flow rates and the duration of that. So there are these three concepts that we can look at. A lot of people will talk proudly and say, this is what I use. I only ever use 250 mils fresh gas flow, and you say, well, yeah, but what about that? Might be in the middle of a long, stable case, but what are you doing across your whole case? And again, comes back to the early stage of the anaesthetic as an example of that. And this is a classic. This was a theoretical example, and then one day I must have been hanging around in the hallway. Can you come and sit? Come and sit in the corner. We've got this slightly difficult airway, and I took these photos. At this stage, you can see they haven't got the airway, and you can actually see on the far left of the screen that the patient is still unparalysed. But they left the flows at 9 litres a minute for about 10 minutes into the case, and the anaesthetist who would consider themselves, someone who was actually mortified when I showed them the photos. But it's a classic example of how you can get distracted by the complexity of the case. We've had insights in 10 of what were then 19 theatres on one campus. In 2018, expanded that with some new theatres to 20 of 30. Now we're getting cardiac surgery, neurosurgery, paediatrics. Some of our paediatrics, about a third of our paediatrics is induced in an anaesthetic room, and we're about to roll it out into some more places, which will give it's going to be really interesting to see what people actually do in obstetrics, for instance, and what we do with things like our clot retrievals. There's some funny definitions with insights. Basically, it uses the initial high flow period until your flows drop below 5 litres a minute, and then you're into the maintenance period, and you don't go back that way. So here's our 5 years of fresh gas flow data with insights. We're staying around that 800 mils. There's some ups and downs which we address, and I'll come back to how we deal with those. We don't take people out the back and give them a severe talking to, not too severe anyway. It also allows us to derive our TIVA rates, and here's the same time period. You can see that in 2020 we were faced with shortages of propofol and shortages of elective cases, so our practice changed dramatically, and then we went straight back onto the trend line we were on. A lot of those ups and downs come every time we have a serious discussion about some of the questions raised about how much should we be doing of which. It's always interesting discussions. You won't be able to see this, but each of these dots represents an individual room, individual theatre, and what its both its TIVA rate and its fresh gas flows. And it's actually interesting, and we could talk about why the theatres with the lowest, in fact the lowest use of vapour, are also the ones with the lowest fresh gas flows. The two down in the bottom right hand corner are two paediatric rooms. They use volatile at about twice the rate of the rest of the block. The other one a little bit along is the cardiac theatre, and they do funny things in there. Oops, wrong way. Dug up this data, which is interesting. This is our choice of primary hypnotic. We don't have data on propofol use before 2016, but what you can see is that we never particularly embraced desflurane use. In the bottom right-hand corner is some similar data from a hospital in the far north of the country. It shows that in 2007, they were using about 40% each of sevoflurane and desflurane, whereas we were using about 8% desflurane. So we all have this problem. You know, this cupboard now is completely full. This is a few years old of those old vaporizers. We talk a lot about fresh gas flows. What we're actually interested in is mils of sevoflurane. You know, a lot of machines will give us that, but and the other related question is how valid. And again, there's modelling to support the two box concept, or the value of that early flow. And I did this very simple sort of analysis a couple of years ago, which showed a good strong correlation with both fresh gas use and what you do in the early phase of the anaesthetic. Took it along to the statistician, the process of writing it up, and he didn't like it. He didn't like my analysis at all, so we spent quite some time, and we've sort of almost got the paper written, so we've ended up using a negative binomial model. That's some of the data that comes out of it. But basically, as you might expect, actually the length of the maintenance phase is a major determinant, but the induction phase effect on the model is way larger than the total length duration, which supports the hypothesis. What's interesting is the fresh gas flows didn't make much difference, but that represents probably our very homogeneous practice. And there's some interesting things which threw the model out a bit, which again partly represent that we have very homogeneous practice, and a few cases that work one way or the other upset that. This is a summary data from basically from this year. I quite like adding in 15th and 85th centiles because they show you where the outlier, they're probably more useful markers of outliers than the extremes, because there's always a reason for someone to be right outside the limits. So you can see when people had an induction fresh gas flow, it was bang on 6 litres a minute, and a maintenance fresh gas flow with a median of 0.75. And remember that in the same way that induction will make a difference to your overall fresh gas flow, if you're running at 300 or 500 mils a minute and turn it up to a litre, or even the system turns it up to 1 or 2 litres a minute, even for 30 seconds or a minute, that will have quite an effect on your overall average. This one's interesting. This is how long we stayed with fresh gas flows above 5 litres a minute. And while the average is, the mean is almost 5 minutes, the median is 45 seconds. So in, more than half our cases of the 10,000 cases in here, the high flow period lasted 45 seconds. As I say, it's quite homogeneous data. The things which flew through the modelling were long cases with extremes of SIVO use, severe multimodal techniques, intrathecal morphine, local anaesthetic, ketamine, lidocaine infusions. People used to point at me and say I was using all these infusions. Now people use way more than I ever did. And we get the occasional cluster with poor practice, and it took a bit of legwork, but we're able to pin that peak in our fresh gas flows back to a couple of cases of just really poor practice. Nitrous oxide we're starting to be able to use. It basically only gets used in our practice in paediatrics and for the induction period, so we're using around about 10 litres. So how have we achieved this, which is I think what Jan wanted me to talk about. It's a cultural thing. We've always been in a low flow. It's been part of the culture, and I've worked in other departments where it definitely wasn't, where it was seen as dangerous. So it's normal. The sort of best practice that we've heard talked about. We've had the various forms of technology, feedback, and there's no doubt the younger generation, wouldn't even dream of turning on the vapour before the airways secured because of all the factors we've already heard about. This is not quite the first machine. This is a mock-up for a different reason of the machine that I first used when I started, and the then clinical director was very proud of that device on the right-hand side, which was an oxygen analyzer, which he'd just bought because he'd sold to the management on the basis that it would facilitate low flows and we would save money by not using as much halothane. We've been using end-tidal control for 12 years. It's pretty normal, used most of the time. We've had a couple of multi-casualty incidents, and it's interesting going back in the data and you see where people are using vapour. They're actually using really low flows. These are people who usually would have come from the ED with already intubated, but it means that people are just using automated control as their default, as their go-to way of practice. We're starting to see a shift in paediatrics. It's a really interesting reflection on end-tidal control that if we compare the total consumption of those induced in the theatre and those induced outside the theatre, there's no difference. And our hypothesis with that is basically, is once the child's taken into the theatre, connected to the anaesthetic machine, the users are just enabling end-tidal control straight out of the box, and if you like, the patient is already primed, so that it just starts off in a maintenance way. I think this was a major contributor in normalising in normalising low flows, and in particularly getting the mindset of that actually what your vaporizer setting is on doesn't matter. It's what's getting to the patient or even coming out of the patient that matters. Unfortunately, we had to give it up when the ISIS came along. So we don't provide individual feedback. Sorry, we don't have an EMR as part of the reason. It's challenging. It's not impossible to track down an aberrant case in the insights data, but it takes a bit of negotiating the hospital's systems to find the anaesthetic record. There are ways people obviously can look at their own practice. There's the gas usage log. We have a computer that basically runs insights that anyone can go and look up their cases. Here's I just went and pulled this one off the other day. It turns out to be a long neuro case where they, somewhere on there, they used 28 mils of SIVO over a 5-hour. I think I know who the anaesthetist was. I think the reports and the discussion are the important bit. So this sort of thing goes out. I try and do it every month, but sometimes every couple of months, or sometimes when I see the data and there's some weird things happening, you try and remind people about about the best way to use the equipment that we've got. It always creates discussion about, are we using too much volatile, are we using too much TIVA, do trainees need to learn to use a volatile, what about when they're going to a place where they don't have automatic control, all of those sorts of things, and the environmental issues. Changing staff is an issue, and it's particularly getting people to understand both our culture and automated agent delivery, and we know how long it takes these things to become accepted. So the reason we've managed to do this is it's part of our culture, but it does require ongoing encouragement. Good data is an important part of this process. I come back to Rick's question about the equipoise. You know, there are unknowns about probably less the effective propofol, more the plastics, and you know, using fairly standard numbers, we on average across this very diverse range of cases, we use a little over 12 mils of CO for about a 100-minute case, which is about 2.5 kilograms of CO2 equivalent, which you could argue is, you know, yes, it multiplies. As I say, there's equipoise about that. And then, as I say, there's issues of training. And here's Jan and I discussing the finer points of anaesthesia.
Thank you.
Thank you.